Okay, this is part 2 of your paper, Gabby. I hope we're going okay and this kind of makes sense. This is partway through your algebra. That was all good on what you found here. Looks like, I think that's fine. The next, right. Now I can only see we've got, this is right. This is Dave's cube, and this is Jan. So the only thing is, yeah, Dave's cube, that's right, we have to add 150 on to Dave's cube, and we get Jan's. But what you've done here is you've added, this is Jan over here, that's Jan. You've added your 150 onto Jan's cube. Because I think if you add 150 onto the other side, it'll work out correctly. You'll end up with 10h squared plus 56h minus 80 equals 0. And then you can put it into equation solver, and I think h equals a height of 1.18 meters, and then once you find that, you'll need to put it back into, we're working out the volume of Dave's, so you'll have to put it back in up here for Dave's cuboid, with that h, and come up with a volume equals in centimeters cubed. Okay, we're good here. That was fine, that page. Right, this one here, we, I hope I haven't mucked this video up now. We're looking at, this was right, yes, you got that there. And now if we have x to the negative 3 is the same as 1 over x to the power of 3. So you've got 1 over 27 equals 1 over x to the power of 3, which means that x must equal 3. Okay, just a little mistake that you made there. And this next one, rearranging, we want to make L the subject, that's right there, and square on both sides, that's right. So it's sometimes easier to take it out of the brackets. From here I would go to s squared over pi squared equals a over L, and then I would cross multiply, because I've got L on the bottom, the denominator, I don't really want it there, so I'll put L up on that side equals a, cross multiply with my pi squared, and my s squared can come down the bottom that way, so then I've got L as a subject. Okay, and the next one, let's go up. What have we got here? We've got, that's right, here. So, 27 x to a quarter I wouldn't, so I've got x equals 27 x to the power of a quarter. Alright, this is multiplying each other, so I need to actually, this is x to the power of 1 divided by x to a quarter. I'm going to divide both sides by x to the power of a quarter to cross this one over. And remember, powers, when we divide two numbers, we actually subtract the powers. So we have x to the power of 1 minus a quarter equals 27. So x to the power of 3/4 equals 27. And you can just put that in your calculator. Well, to get rid of the power of the 3/4, I would multiply this side by the power of 4/3 and multiply that by the power of 4/3, and that cancels out my powers because they're to the power of 1 then. So I would have x equals, in your calculator, 27 to the power of 4/3. If you did 27 to the power of bracket 4 divided by 3 in your calculator, and that would give you 81 as x. And then I was just checking that then to make sure my answer was right. So if x was 81 equals 9 times the square root of 81 to the power of a half is 9. 9 times 9 is 81, which is then true. Okay, glad that worked out. Let's look at the next one. 4. This looks suspiciously like logs, which I'm not good at. I think I'll have to get this checked for you. Taking a wild guess, because I do not like logs. When we have something to the power of x or the power of 2x, you want to bring down those powers, and the easiest way I remember is bringing down powers. We use logs. So if I have a to the power of x, I can make x in the front by taking log a. If I take the log of a to the x, I can put it in the front, times 2x log b equals, I have to take the log of both sides, so that would be 3 log c. So I've got a 2x and an x, so I would have 2x squared log a log b equals 3 log c. I'm trying to solve it, so to find x, I could then 2x squared equals 3 log c divided by log a times log b, and then I can take this 2 down the bottom there, and if I really want to find x, I would have to find the square root of all of that. Now this is just my guess at this one, so I will check with another teacher about this one this week and get back to you if it's wrong. Sorry, no guarantees on that one. Let's look at why dwell on that. Finding k, two values of k that have equal roots. This one here, equal roots, so 0 equals, that's right. Now we and that's right. This is where you got a bit mixed up in here. You had negative 16, that's multiplied by 2k squared minus 1. So that should be 2k squared minus 1, which leaves you with 25 squared plus 30k plus 9 minus 16 times 2k squared would be 32k squared. Negative 16 times negative 1 would be plus 16. So 0 equals 25k squared. Oh, minus 32k squared is going to, sorry, that's going to go back. It's negative 7k squared. And you're going to have 30k. And you'll have plus 25. So if you put that in the equation solver, you'll end up with k equals 5 and k equals negative 0.714. And if you check that, let's put k as 5 in, would end up with x1 would equal negative 3.5 and x2 would equal negative 3.5, and so we've got equal roots. Right, so just a small mistake on starting up on your second line, unfortunately, but you had the right idea. And don't forget to use, I just use equate, once you get to this point here, just put it in your equation solver to give you the roots. Now looking down the page, find a value of k which the equation roots are numerically the same but are opposite in sign. So I'm looking for, when I have my quadratic, the roots here are going to be, if this is 3, this is negative 3. And that kind of that kind of equation, think back to when, if we had x squared minus 9 as your quadratic, that would give you those kind of roots, x plus 3, x minus 3. You want roots that are the same number but opposite in sign. If I had the equation of x squared minus 25, I would get the root x plus 5, x minus 5. So in order to get these roots, the value of our x, this equation is the same as x squared plus 0x minus 25, isn't it? Our x value has a 0 in front of it. The coefficient, we're using the word coefficient, is a 0. And the same with this one. It's the same. If we had the equation for the quadratic, x squared plus 0x minus 9. So when the coefficient is 0, then our roots are going to be equal. So let's try that. We're told back up the top that the equation is 4x squared plus bracket 5k plus 3x plus 2k squared minus 1. So when this bracket and the coefficient here is 0, we're going to have two roots that are the same. So it's just a matter of 5k plus 3 has to equal 0. So k must equal 3 over 5, a negative 3 over 5, in order for us to have the same number but opposite signs as the roots. And you can test that by putting it back in. Okay, that's that one. And is that the end? I think that might be the end of your paper 5. What are we doing next? Oh, it's just the last page where you'd gone to work on that. Okay, so I hope that helps you, Gabby, and I'll do the probability paper soon as well. Thanks, bye-bye.